Hey, what's up, Gomez gang? Today we are going to talk about this negative number within an inequality type of situation. This is not meant to trick you up. It's more of the fact that we need to start plugging in answer choices that match our solution set and answers that do not match our solution set to confirm whether or not we are correct. For example, if I say that 5b is larger than 20, most of you guys will simply divide both sides by 5 and get b is greater than 5. Now, if this was the case, b must be any number that is larger than 5, and when I plug it into my original value, sorry for the blurriness, when I plug it into my original value, my inequality should be true. For example, let's try 6. 6 is greater than 5, so 5 times 6 is 30, and 30 is greater than 20, so I know that that has worked. But I'm not done now. I also want to try a value that is less than 5, because if that doesn't work, then I know I'm good to go. Let's try 4. 5 times 4 is 20, and 20, although it's equal to 20, it is not greater than 20. So therefore, I know that this answer is correct, and I've tried both answers in and not in of my solution set. But I'm going to change it up a little bit. What if now the inequality said negative 5b is greater than 20? Now, most of you guys will still, of course, divide both sides by negative 5 to get my b by itself and say b is greater than negative 4. Now, some of you guys already know that that might be a little bit weird, but we still have to make sure that our answers in our solution set are the ones that make sense. So if I choose a number that is greater than negative 4, let's say negative 1. For those of you who are confused, because I know I've seen it in people's work, negative 1 is here on a number line, negative 4 is here on a number line. Because it is further to the right, further to the positive, negative 1 is greater than negative 4, just in case. So we'll try negative 1, and if negative 1, when I plug it in, ends up being true, then I know that I'm correct. Negative 5 times negative 1 will get me to 5, and 5, however, is not greater than 20. So this answer is a little bit weird. Let's try a number that is not in my solution set. So a number that is not greater than negative 4, so we'll try negative 5. Negative 5 is less than negative 4. Negative 5 times negative 5 is 25, and 25 is greater than 20, even though it shouldn't be based on my answer. Now, most of you guys are able to find the problem, and the problem is pretty simple. Once I divided by a negative number, my inequality has to change. It must be reversed. And in case anyone, maybe that's confusing a little bit, as soon as I divided by a negative number, my inequality must change. Now I can try this again with different numbers that I wasn't using earlier. B must be less than negative 4. A number that is less than negative 4, let's say, is negative 10. Negative 10 times negative 5 will get me to 50, and 50 is greater than 20. So far, so good. Now a number that is not less than negative 4, let's try negative 2. If I do negative 5 times negative 2, that will get me to a positive 10, and 10 is not greater than 20, which means that I know my answer is correct. B is less than negative 4. The purpose of this video is to get you guys to plug in values that are in and out of your solution set to confirm whether or not your answer is correct. There are way too many people here still not checking their answers. Make sure you do so.